Now, here are two very annoying inverse trig function integral formulas. Again, we're not integrating arcsine, we're integrating arcsine's derivative. These go hand in hand. If you can understand the derivative, you can understand how to undo it. Notice that I'm not even bothering to give you the non-chain rule form. Again, it's all reverse chain rule. A lot of times you guys say, oh, is this a reverse chain rule problem? Yes, always. Every single problem is reverse chain rule, just like every single problem is chain rule. You only need to know the chain rule version. Now, this chain rule version has a different crazy thing going on. And the thing I want to highlight for you is this letter A. A squared there. A there. A squared there. And now this is why arctan's not so nice. But 1 over A here, U over A here. Blah. See all those A's? See where those A's line up? You want to change the color scheme. Alright, sorry. Let's just keep it consistent where red will be for the U. So we'll make this green. See how cool that was? U squared here. U up top. U up top. Sorry, U squared there. U prime. U prime. Okay? As always, we have the plus capital C plus the constant of integration. And these hook-offs, hook off. U prime is a hook-off. Okay? Alright. Well, I'm certainly ready to go. Now, those of you with moderate pattern recognition skills will notice that this is the derivative of the function I just differentiated. Meaning, when it's asking you to integrate, it's asking you to go backwards to find the antiderivative. So we already know the answer should be arc sine x over 2. Now let me show you how it is that. Let me show you how I think about these things. Again, what I'm saying is look at example 10. Look at example 10. It's the same thing. It's the same answer. Here I go. So identify. Oh, 4? Is 4 a square? Yep. Is it a constant? Yep. X squared? Cool beans. We're getting good. Now, I should have mentioned this. A is a constant. A isn't constant. A is a constant. That's very important. A is constant. A is a number. Pi, E, root 2, 3, 5, 6, 17, 18, 24, 36. 36 is nice because 36 is 6 squared. Anyway, 4 is 2 squared. So in this example, A equals 2. Why is A equals 2? Because that's 4. And I'm thinking, oh, A squared is 4. Oh, matchy, matchy, matchy. Okay? Now, to make it even clearer, let me try this. Won't let me write. 1 over 2 2 squared minus x squared. See? So u equals x. So if I know that, if I know a and I know u, then this guy's derivative, this guy's antiderivative is 3, 2, 1 arc sine x over 2. U over a. U over a. So I code it. U over A. Yeah? Yeah. Plus C. Come on. You knew it was coming. Now, friends, Romans, countrymen. This integral. What I notice first when I see a problem like this is, oh, it's a fraction. You might have bells in your head saying, oh, log. Log is fraction. Okay. The derivative of the bottom. What is the derivative of the bottom? 8x? Is 8x on top? No. Can I make it on top? No. Oh, okay. So let me try something else. Is it a power rule problem? Is this perhaps a group to a power down here? No. Because the only power this group would have is -1. And -1 is the only one where a group to a power, the reverse power rule, does not work. So instead, we are left with our newest option, arctan. So in this case, this is the u part for x. This is the a part, 25. So I have 4x squared. I have 4x squared and I have 25. If 4x squared is supposed to be u squared, then u equals 2x. Okay? You could think of it as u equals square root 4x squared. This is not u sub, though. I don't want you thinking about this as u substitution. Okay? U equals 2x. Since u squared had to equal 4x squared. Okay, guys? And then a equals 5. Because a squared has to be 25. Oh. Okay? Now I left the space here. In this example, what's u prime? Oh, it's just 1? Good. But in this example, what's u prime? I'm sorry. U prime would be 2. Uh-oh. So, unless you have learned nothing from the course so far, you know that that's okay. I can create a 2 up top. I can create a 2 up top by dividing by 2 on the outside, like that. Now, this will hook off. That will remain 1/2. And then I'm going with this formula. So let me write out the black parts first. A was 5. Arctan has this 1/5. That's the annoying part. That's the real annoying part. Other than that, it's just plugging things in where they go. Oh, sorry. Everyone see the color coding here? Everyone got it? 1/5. 1/5. Blah, 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 blah. Okay, next. So in case you do not have eyes to see, we have 4 more problems. 4 more problems. Again, pause the video. Maybe try them out for yourself. Maybe go do something else. It's been a long video so far. I'm very sorry. Here we go. Okay, so I look at this. I look at this problem. I do not see a square root on the bottom. So the arc sign's out. It will never be arc sign and have a non-square root on the bottom. I'm seeing a plus. I don't think it's a group to a power because the only group I see is the bottom. Oh, so could it be natural log? Well, what's the derivative of the bottom? It's 8x. Oh, it's 8x. Can I create x on the top to make this smooth? No. No, you cannot. No, 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 children. Bad, 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 bad. You don't want to create 8x on top. You cannot multiply by x and divide by x. That's not okay. You know that's bad. You've done this many years now. You may even notice that over here, it is 8x on top. Don't tell anyone. Now, instead, we're stuck with arctan. Arctan is the only option. So, here's my a. Here's my u squared. A squared, u squared. So a squared is 3. So a equals root 3. U squared equals 4x squared. U equals 2x. Now again, if you're thinking, oh, you took the square root of both sides, not really. I'm using a formula. These both have to work out to be positive, okay? It's important they're both positive. You're picking the positive answers. If you are doing the square root, you're picking the positive answers. Check u prime. Do not forget to check u prime. It's essential. Just like every other integration problem. Oh, u prime's 2. Shucks. I have a 8 on top. I have an 8 on top. Now, I've seen a lot of you guys do something crazy. Kind of crazy. Which is, what do I multiply on the top to get 2? I would multiply by 1/4. So I want to divide by 1/4 or multiply by 4, the reciprocal out here. That's okay. That really is okay. You could also just can I make 8 into 2? Yes, I can, by factoring out a 4. Okay, it's the same thing. Do it however you're most comfortable with. It's not a case of you being unprepared. It's a case of it being a little bit weird. Now, here I go. Everything's in a line. I have u prime on top. I have the u prime to hook off. Bam, shoots off. I have the compensation out here. I know what a is. I know what u is. Let's write it out. Which one is it? Arctan or arcsine? 1, 2, 3, 4, 5. It's arctan. Arctan is harder. Arctan is a bit harder because it will not look like a square root. In general, if you see a square root on the denominator, you're going to start to think arcsine. Now, the 4 should have still been out front. The a is root 3. Root 3. And the u is 2x. Oh no, it didn't change color. Done. Mr. Leven. Mr. Leven. Should I rationalize it? Absolutely not. That's crazy talk. You think you guys can rationalize without messing it up? I don't. Sorry. My battery's very low. I don't know if you can see that. That's pretty amazing. Oh, this is going to be fun. Alright, this one I'm going to use a different color for. Here I'm going to use the color orange, or orange. And again, I already spoiled the ending. What is the derivative of the bottom? Oh, it's 8x. So I'm thinking the entire bottom's derivative is 8x. The derivative is 8x. So I have that on top. So this one looks more like, or it actually is, u prime over u. The whole bottom's derivative is on the top. So This is just natural log. Absolute value, of course, 3 plus 4x squared. Now, if you're a BDC student, I do want you thinking about this. Is 3 plus 4x squared always positive? Yes. Done. I'm going to stop this video, save it really quick, and I'll splice it together in a second. Whatever. Okay, I'm back. It might crash in a moment, so I might not use this video. Here we go. Here we go. So, what I notice here is what many of you probably don't notice. Because a lot of people still ask me, how do I do this? This is improper. This is an improper fraction. So, I don't know. Degree top is the professional way of saying it. Is the same as degree bot. The degree of the top, the highest power on the top is the same as the highest power on the bottom. So long divide, guys. You gotta long divide. What about synthetic division? Nope, doesn't work. Because that is not a nice polynomial. If you look at 13, 14, and 15 in succession, you will see how confusing things are getting in BC. And this is chapter 6, so notice how much longer they've had to practice this than you guys. So, oh, I copied it. That's hilarious. So, I had to long divide. How many times do I multiply this to make something like the 8x squared? I'd have to multiply by 2. I'd have to multiply by 2. Let's write that 2 over here. 2 times all of this would be 8x squared plus 6. We're subtracting the entire thing. So the remainder when I long divide is negative 6. So this integral becomes this integral. 2 minus 6 over 3 plus 4x squared dx. Now that part needs to make some sense to you guys. It really does. It really, really does. Split it into 2 integrals, guys. Let's do it. Integral 2 dx minus. I'm going to write this one in black for a very particular reason. That one's easy. Nice color. This one's hard. This one's hard. So why is it hard? Because, again, the derivative of the bottom is not the top. It's not log. It's arctan. It's arctan. It's the same type of arctan before. There's my u squared. There's my a squared. I have to make this into my hook on. I have to make this to be my hook on. So let's check the hook on again one more time just to make sure you're all on my page. A equals root 3. U equals 2x. U prime equals, oh, come on. U prime equals 2. Good. So, I'm going to factor out a 2. I'm sorry, I'm going to factor out a 3 to leave a 2 on the top. 2 hook off. Get a 3 right there. Now, the reason, again, I'm doing it that way is it's a little smarter than you guys multiplying by 1/3 on top and 3 on the outside. It's the same. It just looks a little better to me because that's how I grew up doing it. 2 hooks off, 3 outside. I factored out a 3. I broke the 6 into a 3 and a 2. 3 hooks off. This little baby integral, 2x. Do not lose track of that minus. 3. And it's just very similar to before. Arctan. Something over something plus C. It's not a minus. I would always write it in order. The next one I'll do that like that for you people. The next one might not be like that. Spoiler alert. Green. Root 3. Root 3. Red. 2x. And that should have been a black one from the start. Okay, I'm going to shrink this down a bit. I don't know if that made your computers crash. It might make mine. This last one is one that will require cleverness. The derivative of the bottom is certainly not on top. I'm thinking it's arcsine, except I've never seen arcsine look like this before. Arcsine needs a constant on top. Write that down probably. Arcsine would like a constant on top. Just like tan wants a constant on top, arctan. This one, let's just break it up. That's a valuable strategy here. So I'm going to break this up into an integral of x over that square root John dx plus the integral of 4 minus x squared dx. So all I did was I turned fraction addition, back into addition, okay? I'm always allowed to break up integrals over addition and subtraction, not over multiplication. Stop doing that. Now, last but not least, this one over here. Now I do see a group to a power. This is the nefarious version of this. I see a group to a power. If you were thinking arctan, you're not necessarily wrong. But arcsine. Arcsine, u would be x. U prime would be 1, not x on top. I think I said earlier, arcsine needs a constant on top. It doesn't need a constant on top, but it needs the derivative on top. It would like to have a constant on top. I hope I said it that way. So this guy, u would be x, u prime would be 1, not x. So that's a problem. So I'm thinking group to a power. I'll show you more on that in a second. This one's arcsine. Let's focus on y. It's arcsine with a equals 2, u equal x, and u prime equal 1. Alright? That's the one we started this all off on, to be honest. So over here, I'm just going to write it like this. I want a 1 on top, so I'm going to take the 4 out. So this is what it looks like to be an arcsine. Everything's ready to go here. Okay? Everything's ready to go here. Over here, one more time, let's think about this. It was an arcsine because look, that's what an arcsine would look like. That's not a 1. That's not a 1. That's not a 1. And it would have to be for arcsine. And I can't turn it into a 1. So I'm going to write it with the reverse power rule in mind. X times 4 minus x squared to the negative 1/2 power dx. Group to a power. Group to a power. Group to a power. If I was going to reverse the chain rule, I'd have to do this. What's the derivative of the inside? Negative 2x. I can make that negative 2 as long as I compensate out here. So here I go. Negative 1/2. Reverse the power rule. That hooks off. Four minus x squared. 1 plus negative 1/2 plus 1. Positive 1/2. Divided by 1/2. Plus 4, and I'm not going to do it with as many colors this time. Well, sure. Arc sine x over 2. That's how I write it usually, in that order. Not like a weirdo. You don't have to simplify. Although, you know, if it was if it was a multiple choice portion, you should know that negative 1/2 divided by 1/2 is negative 1. Congratulations. If you got through all of that in one lesson, very good job. Very, very good job. If you got through all that in one sitting, obviously, is what I mean. Most of the videos should be shorter than this. I might break this one up. I'll have to decide. Okay, now, good job. Keep up the hard work. I'm very proud of you if you're making this jump. I want to make sure you're successful at it. Please come ask me questions. Please do the homework. Please make sure you are firing at all cylinders, not just taking this test randomly. Alright guys, have a nice day. I don't know. Keep up the good work.